So you want to use the Path Workbench to generate the G-code for your milling machine. I recently went through this and it's really powerful and really cool. There's just a couple little things you want to know beforehand. So let's dig into it. I'm going to make a mold for a compound planetary gear set, and you can make whatever you want. I'm going to start by creating the objects that I'm going to carve into some machining wax. Alright, now we've got our sun, ring, and planet gears. I now have all of the different gears. They're kind of overlapping here for a compound planetary gear set. We want to add our stock. What is the object that we're cutting these out of? Right? We want to see the actual finished material, what it's going to look like in FreeCAD, and then we can use the Path Workbench to generate the tool paths that will result in that finished, the object you're going to end up with. So we need our wax block, and it's a good idea to start orienting it the way it's going to be oriented in your CNC router or whatever you're cutting with. So we want this corner right here of the wax block is going to be 0, 0, 0. Let's move the rings into position. So we just want them to be inside the subtractive area with room for the tool. Uh-oh. There's not enough room here for the tool. Alright, now we have the objects we want to cut out, and they are positioned so that I should be able to carve them all. My machine should be able to come in from above with its bit and carve everything successfully into this pocket in the wax block, and then I'll fill this pocket with silicone to make the mold, and then I can pour stuff into these cavities in the silicone to actually make the parts. So this is our finished wax block here. So now we go over to our Path Workbench. First thing we're going to want to do is make sure that we've got the right tools, right? So we click on this one, the toolbit dock over here, and that will add the toolbit dock. And then in here we can add a toolbit. You click this to open up the library, and you can do create toolbit, and then you choose what the shape is going to be. And then after you choose the shape and you give it a name, 4mm end mill 2, and that's for the tool configuration file. And then in here you want to double click your end mill and set these properties. If you have the wrong diameter, so let's say this has a 4mm radius, 3mm shank, so this is going to be the wax mold. So we'll select our wax mold and then create a job with it. It's now selected here, and we say OK. So what we're going to do is we're going to use an existing solid. Use existing solid, and then this is just going to be wax block. Everything else is good about that. We don't need to change that. Centroid crashes when I try to export, but I'm using Gerbil, so we swap the output processor to Gerbil. For tools, so now we're going to choose our, let's do the 4mm one we just created. And we want to set our feed rate on the 4mm tool. So this is the horizontal and vertical, I believe. So let's say we want our 4mm end mill to feed at, say, 500. Oops. Let's get in there. 500 millimeters per second, and a vertical feed of 200 millimeters per second, I think. So we'll come over here and make another tool with a 1mm end mill. Double click that, set the diameter to 1. If you don't do that when you set up all your paths, it won't work, and you can't come back and change it. Once you create the tool controller, it copies this info in. We'll make another one here that's an end mill, and we're going to do a 1.3mm end mill. And this one is, I'm going to use a 1mm end mill in the actual machine, but this will give us 0.2 of a millimeter of kind of buffer of where it puts the end mill versus where the end mill actually is. Some of the jobs don't support a clearance or material allowance setting. So by making an end mill that's just a little bit bigger than it actually is in real life, will allow us to do some pathing that has material clearances on it. That's going to have a feed rate of, we'll also, a feed rate of 500 and 200 vertically. And we're going to add one more, and this will be the 1 millimeter end mill, and this will be for the final profiling. And this will also be 500 and 200. I'm pretty sure those are reasonable speeds. I forget if those are good or not. And let's just label them with TC, and that way we know where in the program it's referring to a tool controller with its feed rates and stuff. Work plan we're not worried about yet. Okay. We want to just remove a ton of material with the big bit, and we can do that. Oh, you definitely need 3D Pocket, 3D Surface. I don't know about Waterline, but 3D Surface for sure was crucial for this job. And to do that, I think you have to go to Edit, Preferences, Path, Advanced, Enable OCL dependent features, and then apply. And then you have to close and reopen FreeCAD. And then once you do that, you'll see 3D Surface. We want to have our 3 millimeter bit. We're going to carve out just most of the wax here. And to do that, we're going to use the 3D Pocket, this one right here. So we click that, and we're going to use the 4 millimeter end mill. We're tricking it to leave like a millimeter behind. And then we'll remove most of that millimeter with the next operation, and then we'll profile everything at the end, which will remove the last third of a millimeter. Step over percent, because I'm actually going to be carving with a 3 millimeter end mill instead of a 4. I want this to be something like 50. We're going to start, you click on a plane. For depths, this is important. You set the depths on all of your jobs, on all of your operations. And you click on a plane, and then you use the arrow to plug that value in right here. And then, so the step down is 4 millimeters. You can change it, like it will pre-fill it, but we can change it and say, hey, it's actually going to be a 3 millimeter bit. And now if I tab out, that updates to 3. So in theory, if we apply, we should get a zigzag that's going to carve all the way down to the bottom in a series of passes. So that's a good, like, quick removal of all the material. And in theory, we can even simulate. Okay, so here it's simulating. This is what it's going to look like as it's cutting stuff. So here it is at the end. It has removed. It looks like it ignored these pieces somehow. See, it's a good thing we checked. It looks like it wants to go around them. Like it's going back and forth here, but it definitely thinks that it cut them. Let's watch it till the end and see why it thinks it's going to carve the rings all the way through. There it goes. It's cutting the rings. Oh, no. Oh, I know why. I know why. The rings are 0.01 millimeters up. Ooh, that's it's a good thing we simulated this now rather than like go through all these jobs and ruin everything. So if we go back to our cut 02 and our fusion and our rings, right? These are positioned. They need to okay. So we're done with that. We need to drop them by 0.001 millimeters, right? The rings aren't actually touching the bottom technically. We should see that it's roughed out and it left our rings this time. Perfect. So this bulk removal job looks beautiful now. We are going to turn it off with this one here. Yeah, toggle the active state of the operation. So now it's gone. You can also like show and hide it. But when it's inactive, then it stops like doing all this math on it for the time being. So now the next one, what we're going to do is we're going to go back and forth over the pocket. and really remove the material in detail. So I think we're going to start here, and we want to do a 3D surface. And then a single pass right here. If we did a multi-pass, then it would be very much like the 3D pocket, right? Where it'll go down 3 millimeters or whatever the pass depth is, and then down some more and down some more until it gets to the bottom. But since we've already roughed it out with our pocket, now we just need one pass through. Our tool controller is going to be the 1.3 millimeter end mill. So we're going to leave just a little bit of meat on those bones. Cut pattern is a line, so it's just going to go back and forth, right? You could do zigzag or spiral or whatever. We'll just go back and forth. So step over. So again, we're doing a 1.3 millimeter end mill, but the machine's only going to have a 1 millimeter end mill. So again, we're going to do like a 60% step over. So now our start depth is going to be up here at the top. Our final depth, it looks like it's already got it. Oh no, the final depth was 38, but we only want it to go down to 15. Step down doesn't matter because it's just a single pass. So now if we say okay, boom, 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 up, it's done. If they have a zigzag, let's try that because that sounds interesting. But you can see what it's doing is it's just kind of draping. Here, we'll hide the wax mold, and you can see it's just coming in, and it's dropping down, and when it hits an object, it lifts up to move over the top of the object, and then it drops back down to the bottom again. And you can set how tight it needs to be against the object, and it takes longer to compute, but you can see it how it's got these angles here. It's not like a vertical. And so that means the bottom is going to have more material left behind than the top. And for us, that's a little undesirable because when we do the final profiling, it's going to leave these little spikes of wax sticking out that represent the bottom of the trapezoid that didn't get fully removed by any of the passes. And to do that, there is a setting on the surface, sample interval 1 millimeter. So it just checks every millimeter, what's the height I need to be at, and then it moves up and down as it does that. So we can say, 0.2 millimeters, and that's going to really shorten up the angles on that trapezoid. And let's see if there's a zigzag. There is a zigzag. And, ooh, yeah, that's much better. So it comes down, goes over, comes up, comes down, goes over, comes up, down, over, up. That's going to save a lot of machine time. And if we look at the trapezoids, they're really steep on their edges, which means there's going to be a fairly uniform amount of meat left in between the teeth. If we turn it back on, we can see it's coming in pretty close to the teeth here. If we go under path and path dress up, this is really cool. You do a variety of things like ramp entry will kind of zigzag back and forth as it goes in, so that you're not just directly plunging as you go down, and it will just add that to the existing G code. What we're going to do is add a boundary dress up, which is just going to truncate everything outside the boundary and then do the movements accordingly within the boundaries. Ooh, it's still going all the way up though. So that didn't really solve our problem. It just moved the walls in. It does the slow descent, and then it does a rapid climb, and then a slow descent. Like, it's just such a... Oh, it does a rapid climb to the safe height, and then it does a slow descent. I wonder if we trick it into thinking the safe height is at the bottom. So we go heights, safe height here, -15. Okay. But yes, we have removed those hideous vertical walls. And it's probably a smart idea to save at this point because we've got a pretty decent amount of progress here. We're moving on to the final path profiling, which is really interesting and cool. Oh, I need to change a couple of things. Whoops. So now our surface is good, all our parts are good. Right here, the last thing we need to do is to create a bunch of profiles, right? And so we're going to use this external profile thing here. So for starters, let's just grab, these 4 are the tallest ones, so we'll start there. So we've got those top ones, and we're going to cut out using this one. We're going to profile, and we're going to use the 1 millimeter. We're going to go right up to the edge. The cut side, we want it to cut on the outside of this, and clockwise is fine. It's okay if it goes that way. Extra offset. So on this one, you could say, hey, leave a 0.5 millimeter, and then you could profile again without the offset, but we're not going to do that. I should be able to click that, set it to start at -4, and then if I click right there, and so that tells it from -4 to -10 to cut this profile. So now if we do that, it's going to generate, see these profile where it's just, it cuts it out. So that's cutting out the actual teeth here. And then the next thing we might profile is this one. So we're going to do the same thing here where we're cutting the outside with our 1 millimeter end mill. We go depths. Our start depth is here. Somehow it's not showing us when we select a plane. So I'm just going to leave it alone. But so that goes from 4 to 10. So now let's do this one and this one. These are the 1 millimeter tall profiles, and also this one. No, that doesn't work. So you can't select multiple geometries where one is contained completely within the other one. It will see that these are, it'll only give you the outside of whatever geometry. So if I selected the inside here and the outside here, no matter what, it will never use the teeth because the teeth is completely contained by this other geometry. So I'll only ever be able to get a circle out. These profiles aren't continuous, so it's only those little tiny shapes. So what I'm going to do so that I have the profiles I want in the places I want is just take copies of the planet, of just the larger planet, and copy it into the exact spot. So if I look here, it's 107.36. I can just plug in 107.36, and then for the last one, 109.58. For this one, 109.58. So now I have the profiles in the right spot, and even though these are just sitting up above everything else, all the Path Workbench is going to care about is the XY coordinates of those paths. And I'll specify the heights by clicking on the faces that I want it to cut to. So starting with this, and this, and that, and this, and that, and this, and this. Can't quite select inside of there. That. And we'll do the same thing here, 1 millimeter. We're going to cut to the outside. Direction's fine. And for the depths, we're going to start right there. And we're going to end right there. And then the last profile we need is the insides of these teeth. So we're going to use this face, and we're going to do a profile. And we're on the inside now. So now we can see the last of them, the cutouts of the inside of the teeth here. Everything looks beautiful. So let's turn all of the profiles back on. All right, let's save everything. And then we're going to simulate this bad dog, and we should get like a really good simulation. And here it is in the simulator. We can see everything looks really nice. So there it is. We've used the Path Workbench to generate the whole workflow. I'm just going to export all of it in one go. So we'll turn the job on, and then so you go here to process, and this generates the G code. Yep, save that there. That's smart. Okay, and then here we have the milling operations.ngc or something like that. And here it is. So because I don't have like an automatic tool changer or something, I'm actually going to manually pull the different sections out. Okay, milling operations here. So if we look at Pocket 3D, we go down to the bottom, finish operation here, Pocket 3D. So now we can delete that, and we're going to say Files, Save As, Milling Operations 1 millimeter. And if we go to this one and look for Pocket 3D again, finish operation Pocket 3D, begin operation surface, we go all the way down to the end of profile 5. And now we're going to save this as milling operations 3 millimeters. So now I have two distinct files. I can run the 3 millimeter file, and then I can change the tools manually and run the 1 millimeter file. And we should be good. So fingers crossed, I'll get some footage of that as I run that on the machine. There it is, the FreeCAD Path Workbench, as I've come to use it for carving a wax mold of a fairly complicated object. Yeah, I hope it was informative. Good luck on your projects. Thanks for watching. I love science, and I hope you do too. Boom, 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 boom.